So another kind of graph that does the same kind of job as like creating a frequency distribution and a histogram is called a stem and leaf plot, oftentimes just called a stem plot. A stem and leaf plot is another way to represent quantitative data graphically. In a stem and leaf plot, we use the digits to the left of the rightmost digit to form the stem, and each rightmost digit forms a leaf. The figure to the right provides an example. So this right here is a stem and leaf plot, or a stem plot. So this line right here separates the stem from the leaves. So again, the stem would be these digits over here to the left, and then the leaves would be the digit that's farthest to the right. Now, what I mean by that is this. If you look at the legend down here, 2, 4, and then the line with 0 represents a value of 240. So in my data, 240 was one of the data values. 244 was another data value. 247 was another data value. 252, 252, 253, 259, 259, and so on. So I'm displaying my data. I still have the raw data values showing here, but at the same time, it's displaying it in such a way that I can kind of see the effect that I would get with a histogram, for example. Now, again, we include the legend because it's possible that like the 2, 4 with the line and then 0 could represent 24.0. If that was the case, then this would be 24.0, 24.4, 24.7, 25.2, and so on. Or you could even mean like 2.40. So if that was the case, then it would be 2.40, 2.44, 2.47, 2.52, and so on. Now there's positives and negatives of it. The positive is that if you wanted to retrieve the actual data values, you can do that from a stem and leaf display. You can't do that from a histogram. The negative is it's not very effective if you have a very large amount of data. So if we had thousands of data values, a stem and leaf display is not going to be very good for that because you can't really change the scaling like you can on a histogram. So it's only going to be decent if we have a relatively few number of data values. Another negative is that you can't really control the class width. So in this particular case, like with this data, the class width's 10 because we're going from 240 to 250 to 260 to 270 to 280 and so on. And you can't really adjust that, at least not much. So how do we construct the stem and leaf display? The stem of a data value will consist of all the digits to the left of the rightmost digit. The leaf of the data will consist of the rightmost digit. Write the stems in a vertical column in increasing order and draw a vertical line to the right of the stems. Write each leaf corresponding to the stems to the right of the vertical line, and then within each stem, rearrange the leaves in ascending order, title the plot, and include a legend to indicate what the values represent. So take a look at this next example. The data in the table below represent the percentage of persons living in poverty by state in the year 2017. We're supposed to draw a stem and leaf plot of this data. So again, this is the percentage of residents or citizens who live in poverty. So in Alabama, 16.9% of its residents live in poverty. In Alaska, 11.1%. In Arizona, 14.9%, and so on. This does include DC, so we have 51 data values all together. So I want to organize this data into a stem and leaf display. So most of our data has 3 digits, right? So like, for example, if I'm looking at the 16.9 here, the 16 is going to go in the stem and the 9 is going to go in the leaf. 11 is going to go in the stem, 1 is going to go in the leaf. 14 is going to be in the stem, 9 is going to go in the leaf, and so on. So if you look through this, the smallest level of poverty, I believe, is New Hampshire here, 7.7. I think that's the smallest data value. And the largest is maybe West Virginia here, 19.1. Yeah, I think that's the largest. So when I create my stem, I'm going to go from 7 to 19, and then I'm going to put the leaves in as well. Now, rather than do this one out by hand like I did the last one, I start by creating my stems. So I'm going from 7 to 19 down the stem, and I've got my line drawn to the right. Once I do that, then I go through my data and I fill in the leaves. So I'd go to Alabama. Alabama's 16.9. I'll bring that in. Alabama 16.9. So I put a 9 over here in the leaves next to the 16. Alaska is 11.1. So I put a 1 in the leaves. Arizona's 14.9. So I put a 9 in the leaves. Arkansas 16.4. So I put a 4 in the leaves. Now I already had the 9 there from Alabama, so 4 goes to the right, and so on. So I continue doing that through all of my data, and then we arrange those in order. So like here at the 9, we had 6, 5, 3, 5, 7. So we rearranged that to 3, 5, 5, 6, 7 so that they're in order. Likewise, we rearrange this so it's 0, 3, 3, 5, 6, 7, 8, and so on. Include a legend. Line 7 represents 7.7%, and this is the percentage of persons living in poverty. Not too hard, just a little tedious. If you turn it sideways, you can kind of get the same effect that you get from a histogram. So if I had to describe the shape, it's maybe another one of those that's like bimodal. It's kind of, I would have said maybe skewed, except this one turned out to be really big. And it's not exactly bell-shaped because this one's really short here. If this would have had more values here, then maybe bell-shaped. But anyway, you get the idea. So advantages of stem and leaf diagrams over histograms. Once a frequency distribution or histogram of continuous data is created, the raw data is lost unless reported with the frequency distribution. However, the raw data can be retrieved from a stem and leaf display or stem and leaf plot. Again, the disadvantage is it can only be used generally if you have a relatively small amount of data. Split stems. So if we have a stem graph that looks like this, so line 1's representing 11. So we have 11, 11, 12, 13, 13, 15, 16, 17, 17, 17, and so on, up to 48. Well, this set of leaves is getting really long. So sometimes what we might want to do if something like this happens is we split the stem. So instead of just having a single one here, we have 1, 1, and 2, 2, and 3, 3, and 4, 4. And then anything from 10 to 14 would go on the first one, and anything from 15 to 19 goes on the second line here. Anything from 20 to 24 goes here, 25 to 29 goes here, 30 to 34, 35 to 39, 40 to 44, 45 to 49. So I'm splitting it. So essentially what I'm doing is I'm kind of like changing my class width. Instead of using a class width of 10, I'm using a class width of 5. So again, anything from 10 to 14 would go in the first line because 10, 11, 12, 13, 14, there's 5 values there. And then 15, 16, 17, 18, 19, there's 5 values there. So again, I'm splitting the 10 possible values into 5 and 5 is what's going on. StatCrunch can create stem plots. I'm not going to enter this data into StatCrunch, but maybe I'll use my cigarette data for StatCrunch. So let me show you real quick. So if I go to graph and I can go to stem and leaf, choose the column that has the data, and I'm going to say compute. That's all there is to it. By default, and actually, as far as I know, StatCrunch's stem plots are always split. It always uses split stems. It also rounds the data if it needs to. So like it's rounding this 0.425 to 0.4. So it's just rounding that all so that we either have like to the nearest 10th or we have like 1.5 or 1.6 and so on. So this is like 0.2, 0.3, 0.4, 0.4, and so on. So it's rounded those. Dot plots, to be totally honest, aren't used very much anymore. Technology kind of took away the necessity for dot plots. The significance of dot plots is that we could, if again, this is like prior to having access to a lot of technology, we could create a very sort of crude graph to kind of get a quick visual of how data is distributed. So a dot plot is drawn by placing each observation horizontally in increasing order and placing a dot above the observation each time it's observed. So for example, this plot right here is from the Wendy's data that we used as our first example in section 2.2. So we had our Wendy's data here. So the data value 1 occurred once, so it has 1 dot above it. The data value 2 occurred 6 times, so it has 6 dots above it. The data value 3 occurred once, so it has 1 dot above it. And the idea is that if I'm going to create a dot plot, so again, I have like 1, 2, 3, and so on. If I was going to do this by hand, 5, 6, 7, 8, and so on. So I would go through the data. I see the data value 7, so I put a dot above it. Data value 5, so I put a dot above it. 2, 6, 2 again, so I put a dot above my first dot. 6 again, 6 again, and so on. So it's almost like tallying, like making tally marks. I'm counting how many data values occur, and when I'm finished with this, I end up with a distribution of the data. So like I can look here and I can see how the number of customers is distributed through my data. And so I could describe the shape. If it wasn't for that, I would almost call this bell-shaped. That too kind of messes up a bell shape. So I would probably go with the bimodal option again on this because of that. But if I went with one of the 4 that we were given, I would probably say that's closer to bell-shaped than anything else. You can do dot plots in StatCrunch as well. You just go to graphs and you choose the dot plot option and tell StatCrunch where the data are, and it will do the dot plot for you. Again, no one really does that much anymore. Just because of technology, you can just as easily graph a histogram as you can a dot plot, and so that's typically what people do anymore.